Okay, number 21. The following table presents the heights in inches of a sample of college basketball players. So we've got the height, frequencies, so height in inches, so 68 to 71 inches, 16 people, 72 to 75 inches, 41 people, etc., etc. So considering this data to be a population, approximate the standard deviation of the heights. So this is a population, so we're approximating sigma is the population standard deviation. Now I'll show this in two ways. First, I'll show this using the formula. Second, I'll show using the calculator. So let's use the formula approach. So in order to do that, first I've got to find the formula that we're using. So this is chapter 3, standard deviation for a sample. Standard deviation for grouped data. So that's what we're doing here. We're using grouped data, right? Because we've got frequencies. This is a grouped, where is it? This is a grouped frequency distribution, right? So we're finding the standard deviation for grouped data. Let me go back to it. Where is it? Where is it? Where is it? No. Yeah, there it is. Okay. So now the big difference here. So this is the standard deviation for group data for a sample, because this is the sample standard deviation, S. Our situation is talking about a population. So the difference in the formula here is, instead of using n times n minus 1 in the denominator, for population standard deviation of variance formulas, we use n rather than n minus 1. So this denominator will just be n times n. So n squared in the denominator. That's the difference. That's the population difference. So let's rewrite this formula and see what happens. So here's my formula for sigma equals the square root of n times the summation of, let's look back again, n times the summation of the frequencies times the midpoint squared. Where is my... The frequency times the midpoint squared minus the summation of the frequency times the midpoint, and that quantity is squared, divided by n squared. Let's look back, make sure we've got that right. Instead of n times n minus 1, it's n times n. That's our formula that we'll be using. Okay, so we have n, maybe, if we add all these up, if we sum these values. So we've got 16 plus 41 plus 70 plus 60 plus 15. That's 202. So the sum of the frequencies equals 202. I need the midpoints. For each of these intervals. To find the midpoint, add the limits, divide by 2. So 68 plus 71 divided by 2, that's 69.5. 72 plus 75 divided by 2, 73.5. Continuing, 77.5. 81.5 and 85.5. Those are my midpoints, so I have those. Well, I didn't write it here, but the sum of the frequencies is n. That's n. Okay. Substituting into my nice formula here. So I've got n, that's 202. Now what I need, wait a minute, I wrote the formula wrong. And you didn't even tell me. Squared should be on the outside for the second one. Should be on the inside for the first one, right? Yeah. Y'all didn't even tell me that I'm writing craziness here. Okay. Okay. So what we're saying here is you've got to calculate all of this before you take the sum. Calculate all of this before you take the sum. So I need to square each of the midpoints, square each of them, multiply by the frequency, and then add all of that up. So let's square each of these midpoints. Okay, I'm going to use my trusty calculator. So let's turn it on. 69.5 squared. Let me see how many I can do here without going to the next screen. 73.5 squared. 77.5 squared. Okay, so 4830.25. $5402.25. $6,006.25. And the last two, 81.5 squared and 85.5 squared. 6642.7310. Make sure I have those right. 6642.25, 7310.25. Perfect. So I've got the squares of the midpoints. Now let's multiply that by the frequency. So the frequency times the square of the midpoints. Frequency times each of those. Yes, a lot of steps. Yes, you have to be careful. So I've got 16 times 4830.25. 77284. And then I have 41 times 5402.25. 221492. Then I have 70 times 6006.25. 420437. And then 60 times 81.5. No, not times 81.5. 60 times 6642.25. 398535. And then we have 15 times 7310.25. 109,653. 109,653. That's 0.75. Okay, so that's the frequency times the midpoint squared. Now I can sum these and I'll have this piece right here. Okay. Okay, so 77284 plus 221492.25 plus 420437. Is that 0.5 or 0.25? I don't remember. I'll say 0.5, and if anything, we'll add something or subtract something from it. Plus 398535 plus 109,653.75. So my sum is 1227402. Now let's look back and make sure that was a 0.5. I can hit second entry, and it'll go back until I get that calculation. That was the one times 6006. 1.5. Aha. I'm good. Okay, so there's my sum of the frequencies times the midpoint squared. So that's 1227402.5. From that, I must subtract the sum of frequency times the midpoints. Then I square that entire quantity. So I need to sum the frequency times the midpoints. So let's do that. Frequency times the midpoint. So the first one, let's do it over here. 16 times 69.5. 41 times 73.5. 70 times 77.5. 11123013. Then 5425. Frequency times the midpoint. And then what do we have? 60 times 81.5 and 15 times 85.5. 48901282. And I have to sum all of that. Okay, 1112 plus 3013, whoops, 0.5, plus 5425 plus 4890 plus 15723. This is 15723 squared. All right, make sure I wrote that right. Yep. And I divide that by 202 squared. I'm going to put this all on my calculator. I'm tired of these calculations right now. So second square root, I'm going to put an extra parenthesis for my numerator. Oops, 202 times 1227402.5 minus 15723 squared. Close the parenthesis for my numerator. And I'm dividing all of this by 202 squared. Close my parenthesis for the square root. I hit enter. I get 4.208. So we can say 4.21. Let's, it's approximation. There's your answer there, 4.21. That's if you use the formulaic approach. Now let's see this with the calculator explicitly. Okay, so using the calculator explicitly, here's what I'm going to do. I'm going to enter my data and do a calculation. So here's how I do that. To enter this data, first I'm going to hit stat, because that's going to take me to the menu where I can enter statistics, do calculations on statistics, do statistical tests. This is where all the statistics happens, in this stat menu. But first I want to edit my table. I want to input my values. The way that I'll do that is I'm putting, this is just how I do it every time. I put my midpoints or my data in L1. And if I have frequencies or anything like that, I'll put them in L2. Sometimes you have data without frequencies. So I put the data always in L1. And if I have frequencies, I put them in L2. So my data goes in L1. That's the midpoint. 69.5, enter. 73.5, enter. 77.5, enter. 81.5, enter. 85.5, enter. And then in column L2, I want to put the respective frequency to match them up. 16, 41 in order, 70, 60, 15. Those are my frequencies. So the frequency for 69.5 is 16. Frequency for 73.5 is 41, etc., etc. Yes? Now I go back to stat because now I've got to do some calculations. My data is all there. Let's do some calculations. Go over to the calc menu. And just one variable. Midpoints are the x values, just one set of midpoints. So one variable stats. Now you have to tell the calculator. Some of your calculators might have different, the TI-84 Plus, for example, has a slightly different setup. You have to tell the calculator, my data is in L1, my values are in L1, my frequencies are in L2. Or else the calculator doesn't know, what am I calculating, what are the frequencies, what do these values represent, what is this, what is that. So you have to tell the calculator, you see L1 here, and L2 there. You've got to hit second, L1, comma, second L2. One variable stats, you tell the calculator where the data is first, comma, where the frequencies are second. So one variable stats, L1, comma, L2, hit enter. Calculator does it for you. Gives you the mean, the sample mean here. Well, it's population mean for this one. Gives you the sum of the x values, right? The sum of the midpoints. Well, the sum of the frequency times the midpoints, which is what we have here. The sum of the frequency times the x squareds, right here. It gives you the sample standard deviation, 4.2185. Gives you the population standard deviation, 4.21, which is what we got. Gives you the sum of all the values, 202. And it also gives you some box and whisker plot stuff. It gives you the minimum, it gives you the first quartile, the median, the third quartile, and the maximum value. It gives you all of that information. But what we're interested in, population standard deviation, 4.2 or 4.21 as I have. That's it.